Open source projects rarely become under-maintained because the architecture stopped mattering. More often, they drift because maintainers run out of time, funding, or energy. So today, I invite you to explore whether AI agents can meaningfully help maintain an open source project by using Conduit, a Go-based data streaming platform, as the case study. And I'm excited to welcome William Hill, a maintainer of Conduit, who will walk us through what worked, what didn't, and where human judgment still matters most. This is exactly the kind of grounded discussion we love in this community, less hype, more signal. And with that, please join me in welcoming William Hill.
Thanks, Anessa. I really appreciate it. I got to meet some of the OpenTeams folks a couple years ago. I think very highly of y'all. So, again, thanks to OpenTeams for sponsoring. Thanks to Anessa, for inviting me and hosting this. Thanks for y'all for attending. So, this has been a interesting experiment that I put together really just in the past few weeks. So, tried to get as much insight as I could as quickly as I could. So, gonna jump into it and share my screen, and hopefully we can share some insights and learn together. All right, can everyone see my screen? All right, cool, cool. So again, thanks to Nessa for the invite and the introduction. So yeah, gonna look at can we extend the half-life of open source software. And I'm currently again, William Hill, obviously name on the screen, but currently a senior software engineer at ZocDoc. I was formerly a staff engineer at data engineering startup called Maroxa, which created Conduit. So I got to work hands-on with it and help maintain it and such. So that's why I used it as a case study. So we'll get deeper into that. So the question behind this talk, as Anissa laid out in the intro, is software, open source software in particular, rots. I use the term half-life here. I'm kind of adapting it to my own use here, but I put it as like the rate in which a project loses maintenance capacity once sustained human support declines. So Conduit in this case, again, I used to work at Maroxa, as sometimes startups do, no longer exists, for various reasons, mostly because runway and those type of things. But it was built upon a model of an open source tool, which also then had a managed solution. So as the engineers who were maintaining Conduit went on to, different roles, different jobs, founding new companies, what have you, Conduit had a community of use, but it's kind of just sitting there, right? Because again, a lot of times open source software is a labor of love, where it takes time and energy, to maintain it, but you also have to pay your bills and stuff, right? So whenever there's not a company or a sponsor or something that's, putting time, money, energy into the supporters, then the project just kind of goes by the wayside. So with the advent of generative AI, which I know most of us, if you're not already using it, it's coming. Really for all of us in some way, even though I'll touch on that a little bit, is like, okay, how can we potentially leverage AI agents to revive a lightly maintained tool that at one point had a community, had maintainers, had a active lifeline. So what we'll look at is some of the things that we hope to walk away is the whether the experiment worked, whether your repo is a candidate for this approach. The single guardrail that I, think again from my experimentation matters the most, and how much this would potentially cost you. So again, a little bit more about Conduit itself is the open source data integration framework. If you've heard of like Kafka Connect or familiar with anything like, it's essentially a Connect replacement or a competitor. But with Kafka Connect, all the JVM overhead that you have, so kind of was built top to bottom and go. That combined down to a single binary. So you can see just some stats around the code base, around 70,000 lines, 638 files. Again, to reiterate what it does is batteries included, data integration framework, primarily operating on real-time data. And then the repo health, you see we have 591 stars. So again, a decent amount of people who had eyes on it, 58 forks, 24 active contributors, and 36 releases. But one thing to kind of notice there is when the last release was, which was nearly a year ago. So in June of 2025, there's still 115 open issues and there's still 21 PRs open. But the activity for nearly the past year has been almost entirely dependent upon dependency bumps. So we can even look and see what the last human commit was by one of my former colleagues, Lavro, back in April of 2025. So you can see that this is essentially a a project that's in stasis, right? It at one point had a community that got use out of it, and had active maintainers as it was built and maintained within the companies built around it. But now it's kind of just sitting there on the shelf. So to kind of start to build out the thesis of my experiment, I wanted to look at how Conduit was being maintained while it was under like active sponsorship. So I went and pulled some numbers. So we can see there are roughly 36 commits per month whenever it was under active maintainership, active maintenance and development by Maraxa. So now, as that's no longer the case, we're getting about 8 commits a month. But that's a little bit misleading because, again, that's almost entirely Dependabot. So, because we saw in the previous slide that the last human commit was nearly a year ago. And there's, again, still open issues that are there. Because at one point, there was also like a Discord in which we had a community of like people who asked for features and such as well. But as of right now, it's pretty much dormant. So, what I phrased part of the initial hypothesis was if we could match the velocity that we used to have whenever it was being actively maintained. So, because again, I want to point out like two things here in this particular slide is that we want to try to restore it to its maintenance velocity, just again as a baseline, as whenever it was being actively maintained and using agents that are run semi-autonomously. We also want to also try to stay under a cost cap just to try to, put some more metrics on the experiment. So could we achieve this with minimum oversight, but also with cost? I took this as a very arbitrary thing just because, a lot of open source tools will have like the little banner, like buy me a coffee or whatever. So I was like, okay, could we try to do this for less than the price of a cup of coffee per month? But one thing I wanted to point out here, and just with the state of software industry and such, is I was designing this, and of course you can't control how people use things, right? But this experiment was designed in mind for open source communities, not for corporations that are having record quarters and then laying people off because that happens, unfortunately. So this is designed for like people who are, putting their time, energy, expertise into maintaining open source tools for like the greater good and for like communities as a whole. So looking at again, laying out the basis of the experiment as far as what I built and what I did not build. Um, so I didn't build anything to be like to self-merge PRs because again, we still want to maintain human oversight here. But what I did build was a pipeline that is human governed. It has two human in the loop points clearly defined, and then also some instrumentation to try to decide whether or not a PR is actually worth opening or it's or the issue is worth working on because you can sometimes get PRs or feature requests that are frankly not worth implementing, right? I mean, with the AI agents, ideally that threshold is lowered, right? Versus the human time and energy taken. So you can, obviously you're a lot more judicious with the things that you try to take on. But we still wanted to have some level of rigor around what was actually trying to be contributed to the code base. So the pipeline that was built, I built it using several agents and I went through several iterations and I'll go through the results that I got with this. But at my current job, we use Cloud Code a lot, and we've kind of standardized a little bit on these superpowers. If you're familiar with the plugin superpowers, their methodology of development. So, and again, it follows typical spec-driven development, right? Where you triage the issue, you write up some tech specs, write up an implementation plan, and then you code. So it simply essentially tried to do similar type thing here, where it first triages the issues that's on the repo. Then you have your human in the loop gate one, so you can have a person there to approve whether the issue or not should be worked on. Then we have an archivist To work on it, actually, I'm on the next slide. We're going to actually go a little bit into deeper detail each one of these. But that gets passed to an archivist that then tries to find the relevant files that can need to be potentially changed or patched for that issue. We then have a automated planner and reviewer that then writes up like the plan and then kind of does like this round robin review. And then we have an implementer, and then we actually get to the second human gate of being able to review and approve the PR. So again, just a little deeper into that pipeline. So again, the triage, like I said, it pulls the issues. It does some scoring on label heuristics, recency, activity, complexity, maybe even like labeling. I'm excuse me, it's like severity. And but then, yeah, humans still own the final say of like, should we actually work on this ticket or not? And as I mentioned, the archivist then goes and does a static analysis to try to find the relevant files according to the ticket. And then the planner writes the implementation spec. Implementer then goes off and tries to do several iterations of working on the code. I did put a budget cap there just to try to again adhere to that cup of coffee kind of salary cap, I guess you could say. And then lastly, the human review. So how it's built. So in this case, I built it entirely in Go using Claude Code. So I know, I think it will, I forget the gentleman's name who was talking about at the beginning about like code quality and stuff. I will admit, it's probably some slop in there just because I was trying to move very quickly and I was focusing more so on results than beautification of the code and stuff right now. So might not be the best looking code in the world right now as far as how I built this, but yeah, I was just trying to move quickly just to even start to get some experimentation results to see what feasibility is. But yeah, it's built entirely in Go using I was initially trying to use ADK, Google ADK, and I'll talk a little bit about that. You can even try to see like I have a little anecdote there around like the agent loops are unreliable, but we'll go a little bit deeper into that. And then using Anthropic's beta tool runner. So, and then each stage that we talked about previously generates. That's a typo. That should just say an artifact, not a JSON artifact, because the plan itself is actually in Markdown, and we have a Git patch for the diff. So, kind of putting a little bit of the cart before the horse here, but we can look at just some basic results that we got. So as far as what I did around deploying this, like I said, I wanted to do it semi-autonomously. But actually, I can amend that a little bit just because I was trying to get some quick empirical data. I actually had it to run a little more autonomous, where I bypassed that first human in loop gate. I created a GitHub action where it would run just on a schedule. Because again, I was trying to have it to match the previous velocity. So the nice thing about doing it with the GitHub action, the infra costs $0 on a public repo. But we can see we had 23 run. We only had around 13% success rate and opened it up PRs. And we'll go a little bit deeper into that. And we can also see that we went over our cost cap, where if we extrapolate out how much we were going to spend over a month to get to those 36 runs, we got to around $16 a month versus I'm actually not a coffee drinker, so I don't even know how much coffee costs these days. But yeah, so again, some tweaking there. And actually, let me see if I can open this up. I just also created just a little simple dashboard, pretty much a reiteration of those stats we just saw. But this pulls directly from the GitHub Actions to see just some metrics. So again, I know we already looked at some results, but I try to go back to middle school and trying to use some of the scientific methods around as much as I could. So we have for each iteration trying to have a hypothesis, the method that we do, and then the results and analyze them. So we have some key metrics that we checked out as far as like one, does the build pass? Like, do we produce runnable code? We check in that span because we have a metric around that. The hallucinated symbols. So again, does it actually, try to reference code that is already existed? Or, I have say like reference functions that exist, or is it making up stuff? Is it hallucinating? And then does it actually create a PR? So the first phase, and again, given that I was thinking about that cost cap, I was like, let me try to start with the cheapest kind of thing that I can do. So Gemini Flash is one of the kind of cheapest commercial models that's out there. So I was like, okay, let me just again shot in the dark, see if it works. Excuse me, it did not. So with Gemini Flash, especially given that I was like kind of working in Golang, so I was like, let me try to use like Google's ADK, that's the Agent Development Kit if you're not familiar. That's written in Go. So let me just try to do all Go everything with like the very cheapest thing that I could do. And it was constantly producing what we call like hallucinated symbols. Essentially, it was referencing functions that didn't exist. And also the ADK agent loops were ignoring like tool call instructions. So it was just not, again, it was a very good, just, shot in the dark first iteration, but was not feasible. So we needed to pivot architectures. So in this case, I moved to a more of a mixture of agents type of architecture, where in this case, with the orchestration, like I said, we were getting some issues with the ADK Go agent loops. So I switched to using more deterministic code as far as being able to like actually invoke the agents. So to invoke them more, because I know ADK has like several different modes. I'm forgetting the names off of, but it has like an LLM mode where it tries to determine, via LLM what tool or what agent it should call next. You can also put it in sequential mode where it's like it runs every single step sequentially. I probably could have did that, but in this case, I just like, all right, just went with just writing Go itself to be more deterministic and to run things in a predictable way. And then with the models, I this is why I went with the kind of mixture of agents, where I was like, okay, I'm still going to try to stick with Flash for those first few steps for it's like triaging, planning, analysis, review, and all those type of things. But then I switched to Haiku, so Anthropic's Haiku for actually writing the code. So I tried to, look a little bit as far as which tools would be better suited for the particular jobs in the chains. Was also with the output format for the plans. Again, trying to follow like that spec-driven development. Anytime I was putting out the implementation spec, writing it in JSON, the code was getting broken with some of the JSON formatting. So I actually started putting it out into Markdown. So this architecture pivot actually produced somewhat successful results where we were able to get our first PR. So it was again a very simple thing. It was like, okay, we need some error codes to be documented in Swagger. For some of the documentation that actually gets generated. So you can see here where we use the different models for the different stages. We can see the time that they ran. We can actually see the cost. So we were actually able to get a PR that is still up for about 6 cents. But yeah, so this was a draft PR that was created from the pipeline. You can see again, obviously there's some things that left to be desired, right? Where you can immediately see we didn't adhere to like the PR template that's established for this project. But we got a PR up. CI failed. Uh, so that's another thing that they were going to touch on as well. But we can actually look and I mean, it did stuff. Again, it didn't adhere to like the coding standards established in the project, but I mean, it did some stuff. So yeah, we lost our license that it was like a standard that we have, but we can see we have the error codes that we wanted to add. And but yeah, it's a PR. Is it a good PR? No, but it's a PR. So around this point was when I actually went and spoke with some of my old colleagues, in particular the co-founders of Marata that, again, that created Conduit, created a company around it. And one of them, I spoke to, both the co-founders. One was the CEO, one was the CTO. I first spoke with the CTO of Ali Hamidi, and he was like, interested in the idea. And I showed him like my initial iterations, things I was testing out. And Ali is like, oh, well, let's look at some of these other tools that you can possibly use that you might can almost reduce the cost even down to zero. I mean, I know 6 cents again for a PR, pretty solid, even though there's obviously things to fix. But he was like, okay, let's try to take a look at some of the other things that you can use. So he specifically recommended like Aider and Open Router. So I was like, okay, let me try those out to see how well I can do those and to see if they would actually lower the cost to zero. ran into issues, as we can see here. So I was using Aider kind of like as the orchestrator, and then trying to use a few different open source models that was hosted by Open Router. And I ran into multiple different issues where I was not able to successfully produce a PR that I can even start to iterate on. Some of it was due to like Aider itself. Again, I had only learned about it, so I was very new to it. People may have like better, more experience with it as far as like how to do it or how to work with it. But then even like on the Quinn models, I was running into like still the hallucinated methods, but I was also running into context overflow as well. So as the implementation plan that was being written by the Gemini Flash models was then being passed to the implementer, it was overflowing the context and it was breaking from there. So again, a kind of like result table from the different ones that I tried. I ran several experiments with Aider and using several different open source models via Open Router. It wasn't able to successfully produce a PR that I could even try to iterate on. So again, we can see that again, very small numbers here. We can see that Aider cost is 7% of Anthropic's price, but it doesn't create usable PR. So at least in my experiments and testing. So and again, the um the context budgets was just too constrained as far as the different kind of I guess you can say small language models that I was trying via Open Router. So again, this is some of the things I've already repeated, but like yeah, some of the things I learned around the infrastructure is that yeah, almost. I mean, I can sit there and read the table, but it's essentially some of the issues that I ran into, whether it's again not properly detecting diffs, again going back to the hallucinations, or even like some of the JSON issues that I was running into. So the compile gate is actually an important one though, because again, if the thing doesn't compile, you can see that we blocked 6 broken PRs. We didn't want to try to submit PRs that was not even feasible and actually trying to work and compile. So this was the biggest. I've already touched on this a couple of times, but this was the biggest failure mode that I continued to come across was the hallucinated symbols. So what it would try to do is reference files or functions again that didn't exist anywhere in the code base. So this could be just a function of, and again, I was trying to continue to look for the root cause and stuff, but I think some of it was a function of like the context window because again, we're working with a decently large size repo, and then trying to pass only a few files from the archivist to the implementer, which again could be missing context throughout the rest of the code base as far as like how things work together. So Haiku did hallucinate much less than the other methods that I tried, but it did still run into hallucinations every so often. So again, this was part of like that gates that we try to put both automated and again, that we could pass on to the human to reject or close out, reject PRs. So kind of just another outline of like again the timeline of the things that we tried. So again, we were able to initially create real PRs on a real repo. We tried to then use cheaper models, but what did not work. And then from there, this is kind of where I stopped the experiment, uh just for time's sake, like I said, given only started work on this a few weeks ago, is that we were able to get, you know, somewhere, but like we were not able to reduce costs to zero. So again, this kind of reiterates some of the metrics that we had. And also this was kind of important here is that I would say I probably shouldn't have bolded this to say like it's not a better model because a better model actually would help because we would have a larger context that we can pass into, but the governance layer is also super important. So that's what some of the feedback that I got from both of the co-founders when I kind of like presented this idea to them. So things that I'm not doing yet. So this is kind of getting into like the future work of things that I could try to, as I continue, if I continue to, go down this path and see if I can actually make this really feasible. Right now it's only running against new PRs. So all of the backlog right now, as is, would remain untouched. So it wouldn't burn down any tech debt. There's no auto merging, which I think we probably don't want to do that anyway. Like we would have to be super, super confident in those previous triage and planning steps to do any level of auto merging. So I think again, yes, that would be in one way fantastic, right? Because it helps you push the project forward. It takes some of the burden off the maintainers, but I don't think it's the right approach. Right now, not handling any type of security issues, which obviously is super important, especially in open source software. But that for this small experiment was not being touched, and not doing anything cross repo. Just the models that I was using probably wouldn't even be feasible to do anything cross repo just by context window limitations. So, open questions that I'm still even potentially working on, like the PR that I was successful in opening up, yes, it cost like 6 cents and such, but we made again, if we try to match that velocity, it $16 is not a ton of money, but it doesn't hit the thesis that I laid out initially. So like looking at things like prompt caching, intelligent mixing of like sometimes using Haiku or sometimes using Sonnet. So different things that I could do to try to balance cost with quality and then have better failure mode metrics. So still that hallucinated symbols which we identified was the most prominent failure condition. So trying to figure out better issues around that. And then we kind of touched this on the previous slide, multi-repo deployment as of right now with just the very small framework or very small harness that I have set up. And the small amount of testing and experimentation done, just not feasible to do around multi repos. So again, just it was good to go and talk to again the co-founders of this company. I thought they built something really, really cool. Everybody kind of moving on to other things. So it was just interesting to get their insights around this, given that this was their brainchild. And they both had, again, varying opinions. Like I said, Ali, the former CTO, co-founder CTO, he was talking about, hey, try to use Nanobot, try to use OpenClaw and those type of things. And I definitely was interested in trying those, but like I said, just time constraints. Didn't get a chance to dig into them as much. And Devaris, the CEO co-founder, he was more so talking around like, yeah, some of the human side of it. Like should we move the human review in a different part of the pipeline? Should it actually approve the spec and not just the PR? So should we have like a third human gate? And then like around PR scoring. So he was thinking about some of like the process and governance around it. So which I thought was like really cool. And these are some of the things that I would try next. It's so crazy. It's wild because in the age of like AI, you can have an idea or you can have like even a problem or something, and the next day something new is out, right? So in the time that I tried this, I was like, okay, let me, just put it up on like GitHub Actions or whatever, and like Claude Routine dropped like a few days ago, where like it also could be a potential avenue for trying to do something like this, where you just set up a routine via Claude to run on some cron or some schedule or something. So like that just came out a few days ago as I was again in the middle of my experimentation. Nanobot and OpenClaw, like again, I know specifically OpenClaw was set ablaze on the internet a while back. I haven't personally played around with it, but it's something that again, since I don't know enough about it right now, I have no idea the true feasibility of it, but it's something that I could at least try. And then this is one of those things like if you're thinking about trying this with your repo, and again, take it with a grain of salt, right? Because this is just me experimenting over the course of a few weeks of just like some of the things to consider if you want to try this on your own repo. You gotta think about like CI, which I would say, again, CI, you might can get around that because, especially your CI should run independent. But I kind of put that in there around the idea of like if you wanted to have something similar to like Code Rabbit. where currently in my job, we use Code Rabbit for automated reviews, and then we can essentially set up like an automated loop where you put up the PR, Code Rabbit, reviews it. You have an AI agent to try to address and fix the problems with Code Rabbit. So if you have something like that and that you want to try to set up your CI, you can of course be, burning tokens and cycles. So that's something to consider. Can you do a meaningful smoke test? Because then, if you don't have that compile gate and not have any meaningful smoke test, which you should, you don't get real signal as far as like if you're putting actual usable code out there. Labeling could be something because then that can help with your triage agent around if there's like high ticket items that you should prioritize first or what have you. Multiple language repos could present a challenge to your context window. Under 200K lines, again, context windows constraint. I haven't stress tested that, kind of put 200K as almost arbitrary number right there. And then a human reviewer, like you can have the same problem that many of us may even run into now at our jobs if you're using generative AI. You can put a bunch of PRs out there, but if you don't have that human reviewer to actually like you can still burn a human reviewer out, right? Where that's still the bottleneck is the human's time. Which is why kind of leaning back to my thesis, right? I wanted to try to match the velocity that we had when it was actively maintained, which obviously I can scale up or scale down if you're able to nail this implementation. And then my conclusion, like I said, again, take this with a grain of salt. This was me really just in my spare time over these past few weeks, just seeing what I could get done. And I think this could be potentially feasible, but it'll take a lot more rigor given the time constraints and stuff that I had to try to implement this. Like I said, this was just an idea that I had where I think Conduit was a really, really cool tool. I enjoyed working in Maraxa. So it was like, hey, is there something that I could use with the, things that I've learned in the past 6, 7 months that could be done to keep this conduit from just, being lost to the digital sands of time. This is again my conclusion from a very small experiment that I think this could be feasible, but I wasn't able to get there yet. That's what I have for now.
This is so insightful, William. This is a fast moving pace, and I really appreciate people like you who take the time to give a thought how we can use this technology for the work that we're doing in open source. And there are many opportunities. There's a lot of hype, but there are many opportunities. Well, I will open up the floor, our audience. I invited you all to ask questions in the chat. I see we also can use audio, and I see Yanis raising his hand. Yanis, please go ahead with your question.
Yeah, thank you. Thank you, William, for your experiments and report. Maybe I have a naive question, but you said something about not using agents yet, and like with code base that are more than 200,000 lines. But what if a human is describing what is inside the architecture of the code base so that the agent eventually targets the places that it needs to modify to respond to a PR, and then maybe it may be smarter than using cheap models. I don't know if my question is clear.
I think so. So I am using, I guess agents in some regard, but I think I know what you mean.
Uh,
Um,
uh, just for example, I've seen a lot of people, they have this Claude.md in several times throughout their repository. Yeah, something like that.
Gotcha. No, that makes sense. Like, I think specifically with a Claude.md, one of the things that I've run into, say, like with work, is that Claude.md is also not deterministic, where it'll sometimes ignore commands. Like, I've put things in my Claude.md to say, like, say for instance, a very trivial one. If you're creating a PR or like a commit or something, Claude like take credit for it, which again I can't be bad at it, right? But they'll like to say like um generated with Claude or something like that. And I'll say, hey, I'll put in my Claude MD, it's like, hey, don't put that. And they'll still do it. So with a Claude MD, it can be inherently flaky. You can do some things like hooks that provides a little bit more determinism, but I think one of the things, even if like given how well you describe it, there's still gonna be like that risk of like the non-determinism where, especially if you have like a sprawling code base, um, of it, potentially um not uh creating the PR or the patch in what you expect. I think what your idea probably pushes it closer to feasibility than the things that I did, but I think there's still some gotchas there.
Oh, I see. Thank you so much. Yeah, I see.
Hey, I got a question. First of all, it's awesome discussion and appreciate the experiment. A lot of people are doing this, but they're not really sharing it. I have a friend, he's working on software factories. So I think a lot of people are trying to create these software factories, which is basically, I see what like your experiment was trying to do in sense of not create software from greenfield, but brownfield in terms of maintaining it. But I can relate to your tooling thing. You mentioned you figure something out, you make a custom tool, and tomorrow Anthropic just made it. So it's like all your effort, all your work is meaningless. So I've actually personally I've switched from how do I create this crazy custom um what do you call it, scaffolding, and I almost go vanilla Claude now, Claude Code. But one interesting experiment, if you keep continuing this, and it would be awesome if you do, you can pass commands into Claude Code. Claude Code's source code was reverse engineered because it was leaked. Well, it was leaked a few times, but that might be an interesting starting point too. They have built-in methods on how they like if statements, if you will. I'm gonna use a cheap model or a thinking model or really expensive model, and some of it's based on cost. So you could use that, but I kind of agree with what the CEO you talked to. Custom tooling is by next week it's over. And even like non-custom tooling, even if you're using something like, oh, here's a cool agent someone shared in a week, it's useless almost. It's like there's something new, there's something different, and it's hard to stay up to date. But this is pretty awesome. Sorry, I don't know if that was really a question or just it would be interesting if you try to leverage some of those tools automated, even if it's like a dumb, like a sub process call, send the command there and see what happens in terms of leveraging some of the tooling out there. I'm not a big fan of Aider as well, but that's just because um, I don't think it's as well. I don't know. It's hard to compete against Anthropic, right? So, but anyway, super awesome talk, man. Um, yeah,
Yeah, yeah. Thanks for the insight, man. Like, yeah, that's the challenge, man. Like, yeah, you build something in Anthropic, man. They're just a machine right now. But I think the only, like I said, the concern and stuff, and to their credit, they're putting out high quality stuff. It's like you always worry about like vendor lock-in,
right.
because especially I don't know. I'm pretty sure they're VC funded. I'm almost positive they have to be. But it's kind of the thing, right? Like that's why one of the things I was talking about with cost.
Yep.
And I'm glad there's the open models out there, the open source communities creating models because I think there was something even just this morning that I read around Anthropic enterprise where they changed the pricing model.
Mm,
And that typically is what happened, right, with VC funded stuff. Is you think about like back in the days of like how cheap it used to be to take an Uber, but then VCs come calling
yeah.
for the return, and the price is going to go up, and now you're kind of locked in to this particular like this vendor that you built your infrastructure around, and now your prices have exploded.
Right. One
So
interesting technique you could try to, I think it's using one of these models to build that plan out, like a more expensive model costs you whatever, and then start feeding the work down and feathering it out with the cheaper ones actually does the actual work. But at the end of the day, you're vendor locking, you're using something to do this really intense planning, which, gives them all the information you're trying to do. But yeah, no, it's pretty cool stuff,
absolutely,
man. I'm gonna
thank you.
share.
I think
Is it
okay.
cool if I share? I'm sharing your repo with a couple friends. I try to get them to join, but I think the link expired or something right when the thing started. I don't know if you have the
Yeah,
slides too to share as well. Cool.
yeah, absolutely. Again, this is open source, right? So we're in the spirit of sharing, which I can't remember if I've actually pushed like my I guess my harness or whatever you call it up because again, I was trying to move so quickly just to get my experiments done, but I will do that. But yeah, happy to share anything, out from this talk. And I do want to say I think that's a fantastic idea around almost I guess you should say switching the the cost vectors around where I was doing it. I was putting like the most expensive thing at the end where maybe like the like you said, if we do spend more like that measure twice, cut once, right? Where if we spend more time, energy, money on the planning phase, then the writing the code is then just mechanical. So that's a really interesting thing to try. Like again, just in my haste, I didn't think about that, but I think that was something I will try. So thanks for the idea.
Yeah, no worries. Thanks again for the talk. Yeah.
And on the topic of sharing, so we are still recording, we're still rolling, and I love the Q&A. This is where I feel like we are at our best, this exchange of ideas. And I'm sure we will be thinking about this conversation well after this meeting. I'm going to upload the recording of the presentation in about 2-3 days. So keep your eyes out on inbox. And also, if you're part of the community, there will be follow-ups on the mailing list. And also, if you're not part of the community just yet, we will share the same information on the LinkedIn feed. And I shared all the links in the chat. For those of you who joined later, I will copy paste again so you all can see these links. Yes, if you have more questions, please ask. We still have about 5 minutes for this event. And if nothing comes to mind immediately, that is fine too. I know it's Thursday and many of us still have work to do. William, I truly appreciate your time with us. It was truly insightful. The moment you reached out with this topic, I thought this is exactly what we want to talk about because there is a lot of like doom around AI, affecting open source, but also, like any technology, we need to look at it through the lens of where it's useful, and it sounds like it is useful. Yes, and to our attendees, thank you all for spending time with us today. I know you have a lot of options, work and otherwise, and I really appreciate all you being here, really.
Yeah, thank you. I want to, extend my gratitude for again Inessa and Open Teams for having me, inviting me, and to everyone attending. I hope you were able to learn something.
Well, let's keep the conversation going on all the communication platforms that I mentioned and shared in the chat. Okay, and until next month.
Cool. Thank you, Ines and William. Bye-bye.
Thanks, y'all.
So.
Thanks, William. Thanks,
Bye.
Vanessa.